Hi, I am Suhan and today we are going to see binary tree Inorder Traversal. Sorry for the inconvenience or the voice behind, it's of the train. Given the root of a binary tree, return the Inorder Traversal of its node values. You can see here the question. Inorder Traversal means we have to go in order, or you can say we have to first go to the left, then middle, then right. You can understand more easily with the example here. Here we have to go first 1, 2, 3, or it's not like that. We have to go 1, 2, 3. It's 1, 3, 2, as 1 is the smallest, and then 3 and then 2. If you don't understand this, then you can check videos on binary tree Inorder Traversal, or you can check Inorder Traversal and what it means. It basically means that we have to go to the left, then the middle, then the right. In this we can see that the left is none and the right is this node. So left none, 1, then this node, not this value, this node. And in these nodes do the same, left, middle, right. In this left, and here the node is the value, so 3, then middle, 2, then 1. If you understand this, then solving this will be a piece of cake for anyone. You can see here I have used recursion for this. I am calling the function return node here, and in this function first I am checking that the root is valid or not, and if the root is valid, it goes to the left first. If it goes to the left, then it goes to the middle and then to the right. In this, what is happening here, if you take example 1, then it is going to the root of left, which is none, so it will return itself. Then we come to the second line, it will append 1. Now after it we will go to the right of this, which is 2, and it will run again, and we will first check the left, which is 3. So it will run again, it will check the left of the 3, means left, and it is none, so it will go to the second line, and after it will append the value 3, and after it will check for the right, as 3 has no right, so it will stop here, and it will again come to the second one, which will here in this recursion, and it will add 2 to it. So if you don't understand it, try it yourself. You will understand it, as it's a nice solution and it is using recursion. And recursion can be a headache if you don't really understand it. You have to take a feel of it to understand it. Here you can see my runtime was 24 milliseconds and it is 93.89%. So thanks for watching, and you can see that I tried 3 times and it kept on increasing. I made some adjustments here and there so that it can be the best solution you can get. So thanks for watching.